And welcome everybody to another one of our cosmology segments. Fascinating stories to cover today. Too many to cover during the daily space weather video, so we had to make a separate video. Here it is. First thing we're going to talk about is Betelgeuse. Betelgeuse is the largest single object visible to the naked eye. So in the very conspicuous constellation of Orion, you can find Betelgeuse when you see these three belt stars. Draw a perpendicular line from the belt buckle, and it will connect to Betelgeuse, a red supergiant star. Now, red supergiants are extremely volatile stars. They are known to produce massive stellar spots, and the dimming of Betelgeuse has been well documented among the cosmology community. The real question is, how come? Well, here's another theory as to why Betelgeuse has dimmed, as there's been all kinds of theories. It's going to go supernova. It's because of a cloud of dust in between us and the star. Here's another theory having to do with concentrations of cyanide and titanium oxide. The possibility that stellar spots have caused the dimming of Betelgeuse. So perhaps massive sunspot-like areas of magnetic convection and organization have appeared on the surface of the star. And this article from SciTech Daily is talking about this. So if you want to have a read, just head to scitechdaily.com or feel free to pause the video. We're just going to let the whole article scroll. You can also find links to some video content as well as the paper printed on yesterday, August 5th, 2021 in Nature Communications. Next, we'll look at the astronomy picture of the day, and it's quite spectacular. You can find it yourself at apod.nasa.gov. And this is a series of objects. You can see a globular cluster here, as well as some new new general catalog entries. So up in the top there, you've got, that's NGC 6726, 6727, and 6729. And again, a globular cluster down here. This is a molecular cloud. There's quite a bit of complex stuff going on up there. And this imagery includes X-ray. We've got Herbig-Haro objects, which are like protostars, I'll say. They're associated with energetic newborn stars. And of course, I won't get into stellar life cycles in this video. We've never seen a star get born or die, though. So that's kind of important. Anyway, there's a lot of X-rays coming out of there in these blue areas that are reflected by cosmic dust. There's a close-up of that. Quite a spectacular region. And leave us a comment if you want to know what's going on in these areas. Now, that's probably hydrogen alpha. I don't exactly know what the wavelengths are here. It looks like we've got a composite of either radio or infrared, as well as visible light and X-rays. What a splentacular scene there. Spectacular imagery there from a combination of various different observatories, including the Chandra X-ray Observatory and more. It's the astronomy picture of the day. apod.nasa.gov. Sometimes they're a lot better than other times, and we actually saved this one for future posterity. And here's that globular cluster again. Interesting portions of galaxies are these globular clusters, wouldn't you say? And continuing on to invite you to our own website, smAshomash.com. If you haven't checked it out, smAshomash.org will redirect you. You can find our social media, as well as links to our merch shops and our forum. You're all invited. And by the way, welcome to the Neo-Renaissance, as various aspects of science are always being rewritten. Let's talk about V404 Cygni. So this is a high-mass X-ray binary located at about, I believe it's about 5 or 6,000 light years in the Milky Way galaxy. And this high-mass X-ray binary features a massive radio source orbiting a companion star. And there's an article here about this extreme X-ray outburst. So these graphs here, these are all X-ray outputs. And back in 2015, or around about then, there was a massive burst from V404 Cygni. Here's the daily chart. We actually saw a miniature burst here. Not nearly as powerful as the one back in 2015. Is it 2015? 2014, I guess. Anyway, it's a huge X-ray outburst there. If you want to look at this yourself on the Neil Gorell Swift Bat X-ray Observatory, V404 Cygni is entry number 939. So here we're going to zoom into this, and what we're looking at here is infrared spectroscopy from the 2MASS. And we'll just zoom all the way out so you get a little perspective here. This is the Milky Way galaxy in infrared, and the galactic core is someplace. Let me just refresh here. The galactic core is way down here in this area. So I don't even think it's actually on this 2MASS data. I'm just going to zoom in, way in, to the constellation Cygnus in infrared. So when we zoom in here, getting closer and closer into the Cygnus constellation, here is this high mass X-ray binary. And we actually see 2 points there. And one of those is the massive radio source. The other one is the companion star. And if we look at this in different spectra, we're going to actually go up the spectrum here. Here is Pan-STARRS optical spectra combined. And it looks like the companion is actually to the north. If this is north, let's just say that's north. The companion is actually to the north of this. So there it is in optical. There's no way that's a foreground star or anything like that. So there you can see the full X-ray binary, both bodies there. And let's go up the scale here. Once again, we'll go a little bit higher frequency here to ultraviolet. Here it is on the Galix, and it's not showing much of anything in ultraviolet. And when we look at X-ray, we'll see just one signal there. And again, if we zoom way out, you can see the galactic disk here as we approach the center of the Milky Way galaxy. It's V404 Cygni, the massive X-ray binary, entry number 939 on the Neil Gorells. Let's just put it back into infrared to close out this section of the cosmology segment. There it is in infrared. Continuing on to show you the reason why we covered V404 Cygni in the first place. It's a phys.org article in their astronomy and space section about these massive rings in X-ray. So some new imagery it looks like here from the, okay, so it's located at 7,800 light years, 7,800 light years distance, and it's got these massive X-ray rings, a very interesting looking feature there. Is it an indication that it is a polar and that there is a jet or a flux tube of material down which we're looking down the barrel of? It could be that. But in any case, interesting article here from phys.org's astronomy and space section about V404 Cygni, massive X-ray binary. So some theories as to how the light gets scattered this way and how it's illuminating dust in the background. Continuing on, where do the heavy elements come from? Do you have any ideas? And of course, we just covered a story about Betelgeuse being looked at in titanium dioxide and cyanide emission spectra. But the real question is, folks, where are the heavy elements in the universe coming from? Are they coming from the cores of supernoval explosions which destroy stars and blow them apart? Or are they just coming from the surfaces of stars and from the surrounding area caused by some sort of nuclear fusion processes? Well, the answer is probably on the surfaces and not from the cores of supernovae. Just because we see heavy elements in supernoval clouds doesn't mean those stars have been destroyed. Since we typically always see a star in the center of a supernoval explosion, the theory that it destroys stars is just silly to me. So here's some, this is neutron capture scenarios here. And of course, beta decay is an issue where a neutron decays after a very short period of time into a proton and a high energy photon. This one's talking about magnesium 26, neon 22, and the isotopic scenarios that occur. Also elements like selenium, krypton, rubidium, strontium, and zirconium. Are stars making these things on their surfaces, in their atmospheres, and in the local environment? Or do these require supernovae? Well, it's looking less and less likely that they do require supernovae, but in any case, let's don't castrate stars in theory by not allowing them to make the heavy elements on their surface. We certainly see it happening on the sun. We show all the time the emission spectra of the carbon around sunspots. So maybe check out this article as well. From SciTech Daily, investigation into the origin of elements in the universe yields new insights. What do you think? Let us know in the comments about where the heavy elements come from in space. Last but not least, another phys.org article in their astronomy and space section. We spend a lot of time talking about the sun. Now, the standard concordance model doesn't really add up to the observations that we see, which is why we've solved the solar puzzle as to what mechanisms cause the solar sunspot cycles and the solar polar field reversal cycles. Let's just say they're more than related. But in any case, somebody's been studying, Dr. Jeffrey Vassil has been studying the sun's convection zone. So certainly convection is something that's happening on the surface of the sun, especially, places like I'll say the upper chromosphere. And for you new viewers out there, the chromosphere is the portion of the sun that we're looking at when we look at specific wavelengths, like 171 angstroms. That's all references to the ultraviolet emissions of specific ions located in the chromosphere. And these mechanisms are kind of important because if we could do things like forecast sunspots, forecast solar flares, and forecast coronal mass ejections, we're only checking one of those boxes, as our channel does indeed forecast coronal mass ejections. The more we know about this, the more important it is. And I consider heliophysics to be cosmology because I do not accept the current mainstream standard concordance model of stellar evolution. So I don't particularly believe a lot of the sort of mainstream stuff about how the sun works. And I'm working on alternative explanations. It's part of what the channel does. Anyway, thanks for tuning in. That is today's cosmology segment. Make sure you check out the other cosmology segments on our playlists. You can find all of our playlists at youtube.com/smashamash/playlists. Thanks for tuning in. And please support the channel via the links below.